The salt doesn't change every time. You just put a salt in, as it were, hardwired into the code, and use that all the time.
Yeah, the best method is to have a different salt for each password. And then what you do is you store the password as the hash, and you store the salt just in plain text. So.
But then I think at the table they get the salt.
Well, then you kind of get into, well, do I store the salt somewhere else? The problem with using the same salt on everything is there's a particular attack then that can be used where if they can create a couple different passwords and they know the hash doesn't change, then there's a way of discovering what the hash actually is. So by having a hash that doesn't change, or I'm sorry, having a hash that changes for every single password makes the job just that much harder for the attackers. And if you really wanted to, you could encrypt the hash, make a random hash, encrypt it, store that along with your thing. It just kind of depends on how much work you want to put into it. And the other thing you can do too is have what's known as key strengthening. That's where with the hash you iterate it. So you hash it, and then you hash it again, and you hash it again. The recommendation from the experts is that you do it at least 1,000 times. Because what you don't want is a hash function for your passwords that's fast. It seems counterintuitive. You think, oh, I want this really fast website. You're only going to check the password when they first log in. So it's not something that, since it's not happening on every page, it's not something that has to be fast. And the reason you want it as slow as possible, within reason, is then when an attacker wants to brute force it, say they get into your site, they discover the salt, they discover, they discover which hash function you're using, they figure out what iteration you're using. Okay, you did it 1,200 times. Even with all that information, in order to reverse it, they then have to go through and brute force it. So they have to just start trying to generate a manual rainbow table, basically, until it matches. And that means that with something that iterates 1,000 times, it's already 1,000 times slower for them to do. It's very quick to iterate once and find the password. It's a lot harder to do when you got to iterate thousands of times, especially with a really big, long salt. So, answer your question. All right, message authentication code, MACs. They're very similar to a hash, but they take a secret key. And the great thing about them is that they protect the integrity and the authenticity of that hash. And using that secret key, then you can confirm that it has not been changed in transit. So that's what you should be using when you send data to the client you want to get it back. On Lasso, we have an implementation called Encrypt HMAC, and it's based on RFC 2041, and that's sort of the standard you'll see on the internet. It's a good algorithm, and what you can do is you can see how it's used. So essentially, it's very similar to using a hash, but instead this time it includes the password, and using that password that you can validate and authenticate that the message is correct. So for the recommendations for Lasso, always use HTTPS whenever you can. It would be great if you used it for absolutely everything. So when people come to your site, they're always using SSL, right? However, there's some expense to that. A lot of people tend to use it for just logging in for the passwords, and then everything else is over unencrypted channel. It's not as nice, especially when you're traveling and you're using unknown Wi-Fi networks. In that case, I'd recommend you use VPN. Also, don't use JavaScript encryption. You'll see that sometimes you'll see where a developer will try and use that to decrypt things on the client side. They think they're tricky or something. You know what? You have SSL for a reason. It works really well. It's hard to break. So, and JavaScript encryption, where you're really going to trust some function you found on some website somewhere. Not only that, but if it's over plain text, in order for them to decrypt it, they have to have a key, right? In order to have the key, you got to transmit it to them so the whole thing can decrypt. So it's at some point you're going to expose the secret that's needed in order to break it. So for symmetric encryption, I recommend either using Encrypt Blowfish, which is still considered fairly strong, or the Cas5 CBC encryption. Which one you choose is kind of up to you. I don't know which one is stronger, or I don't know which situations would be better for which. And then for passwords, when you want to hash, I recommend using the RIPE MD160 because you're not sending the hash anywhere, so you don't need to make sure the integrity is the same. When you're sending round-trip data, using the Encrypt HMAC, use the SHA-1 as the digest, don't use MD5. If I haven't been explicit, MD5, completely broken. You don't want to use it for anything. Remember to, unfortunately since we don't have this high-level API, remember to always build in some sort of method for key rotation. You don't absolutely have to, but there will come a point in time where you're going to want to change the algorithm and you're going to have to deal with it then. So having an easy way to rotate keys and to change your algorithms, especially as new ones come out or are available, it's better to just upfront allow for that. And then going back to the hashes with the salts, the best thing you can do is to use a unique salt for every single hash. That makes it a lot more difficult to brute force. It makes it a lot more difficult that given a bunch of hashes to determine what the salt actually was. Key strengthening, where you iterate through the hashes at least 1,000 times. You have to try on your server. If you got some smoking server, maybe 2,000 times. The slower you make it, that still allows the user to be responded to in a reasonable amount of time, the better off you're going to be. And then always, always, always protect your passwords. Don't store passwords within the web root. There's someone on the last duck list who had his server broken into, so any data that was sitting in the web root, assuming that his FTP only allows for access to there, then it's all in, they probably downloaded everything. So they would have access to any passwords that are stored within the actual web root. So it's always better to put it into either a custom function, a custom tag or something in Elastic Startup. At least it's outside the reach of the web root, and you can still get to your password. You use it when you need it, but at least it's not exposed so much. At least for someone who's just doing a drive-by. Obviously, someone more determined will probably read your code, figure out that at some point the password shows up in this particular way, and then they can write some code to expose it. There's just, unfortunately, there's no way to use a password without knowing the password. The only exception to that is if you actually build custom functions or custom tags that have in your Elastic Startup that have the password embedded in them, and you're not actually accessing, you're not asking for the password and using it in your code. Instead, you're using this custom function. You say, maybe it's just encrypt this word, and you just trust that this, and then it goes and uses it. And then, does that make sense? I'm kind of off the cuff here. So that way, the password never has to come to the application level. It's used within the custom function, stays in the custom function. I keep saying function tag, and it, and it decrypts it for you without the developer even having to know what the password actually is. That makes sense? Yeah. All right, good. Everyone's kind of looking at me. All right, I'm trying not to talk too fast today. All right, some things you shouldn't do. Don't store passwords in plain text. I know it's tempting. There is that one exception. I don't recommend you use HTTP authentication for the simple fact that you have to store it in plain text. It's tempting because users will say, "Oh, I forgot my password. Can you tell me what it is?" And if you're in, a corporation or something or a business, and it's tempting to do it, but don't do it. Don't use the same salt for all your passwords. It weakens it. Don't use MD5. It's completely broken. Use ECB mode when you have a choice because, don't use ECB mode when you have a choice because, as you saw, the macro image is still there. It doesn't do a very good job of encrypting. CBC is the one you want to use. Don't use the same password for absolutely everything. It's tempting because then you only have one thing to remember, or you only have to store it in one spot. But it's, again, once they get that one password, now they have the keys they can